integrations of fractions resulting in logarithms. So it's important to note that this title was not the integration of log, it was the integral of fractions that result in logs. Because we don't want to be integrating logs. Not in this video anyway. So we're going to look at our basic one is if we have the integral of 1 on x, this is an integral of a fraction resulting in a log because the integral of 1 on x is log x, because we know if we differentiate ln x, we get 1 on x. So it makes sense that the integral of 1 on x is ln x. But a more generic formula we can use is the integral of f dash on x over f of x dx equals the log of f of x plus c. So in this one, the derivative of x is 1, so the derivative of the denominator is in the numerator. Just like in this one, the derivative of the denominator is in the numerator. And it ended up being the log of the denominator. So it ends up being the log of the denominator. So let's look at some examples. What about the integral of 3 over x dx? So what we want to be looking out for is that the derivative of the denominator is in the numerator. And the derivative of x is 1, but that's not what we have in the numerator, but that's okay in this example, because what we can do, if we're multiplying a function by a constant, we can take the constant outside the integral. So another way to write this is that it's 3 times 1 on x, and if we're multiplying by a constant, that comes outside the integral, and we just have 3 times the integral of 1 on x, and so we get 3, well the integral of 1 on x is ln x plus c, so we get the answer as 3 ln x plus c. So what about 2x over x squared plus 1 dx? Well, we're checking, whenever we have the integral of a fraction, the first thing we want to check is the derivative of the denominator in the numerator. The derivative of the denominator is 2x, well that is the numerator, so straight away we can write the answer as that it's log of the denominator plus a constant. What about instead of 2x if we had 3x? Because we know the derivative of the denominator is 2x, but we don't have 2x, we have 3x. So what we want to do is we want to take that constant outside the integral, so we have 3 outside of x over x squared plus 1 dx, and the derivative of the denominator is 2x, but now we've just got x, and we want a 2. So what we can do is we can put a 2, because it's just a multiplying by a constant, but that changes the question by just chucking in a 2 there. So we want to also divide by 2 out here, because 2 over 2 is 1, and it's like multiplying our integral by 1. So we haven't changed the question now. But now, 3 over 2 is just 3 over 2. And now the integral of this, because we have the derivative of the denominator in the numerator, it'll just be log of the denominator. So we get 3 on 2 log of x squared plus 1 dx. Let's have a look at one more example. The integral of tan x dx. Well, another way to write tan x is sine x over cos x. And if you haven't learned how to differentiate trig functions yet, this one will be worth coming back to, because the derivative of cos x is minus sine x, but we don't have minus sine x, we've just got sine x. So I can go ahead and multiply this by minus 1, and then multiply the outside of the integral by minus 1, because a minus times a minus is a plus, and we haven't changed the question. But now, the derivative of the bottom of the denominator is in the numerator, So we can write this as minus log of cos x plus c.